The World Gold Council, WGC, is a representative organization of the global gold mining industry, providing guidance, standards, and research to promote responsible gold mining. Their mission is to ensure that gold is mined and produced in a safe, sustainable, environmentally responsible manner that benefits local communities over the long term. The WGC conducts extensive research on the gold market, providing information and analysis to investors, governments, and other organizations. The current gold mining and processing process involves many complex steps, from determining the gold reserves in a mine to producing pure gold ready for the market. Before mining begins, member companies will conduct detailed geological surveys to determine the gold reserves and assess the environmental impact. Geologists will use methods such as exploratory drilling, magnetic field measurements, and soil analysis to better understand the reserves and characteristics of the gold mine. Mining must comply with local laws and international standards. Companies must apply for mining permits and conduct detailed environmental impact assessments to ensure that the mining process does not harm the natural environment and public health. There are two main methods of gold mining: open pit mining and underground mining. Open pit mining applies to mines with ore close to the surface. Rock and soil are removed to expose the gold-bearing layers, which are then transported to a processing area. Meanwhile, underground mining is used for mines deep underground. Tunnels are dug to access the ore, which is then transported to the surface. Once the gold ore is mined, it is crushed and subjected to further processing steps to separate the gold. Processing usually involves methods such as cyanide treatment and carbon-in-leach, CIL, or carbon-in-pulp, CIP. Cyanidation method is the most common method. Gold ore is dissolved in cyanide solution. The gold is then separated from the solution through absorption. Meanwhile, in CIL or CIP method, the ore is immersed in cyanide solution. Then the gold will stick to carbon particles, making it easy to separate the gold from the solution. These methods strictly follow the safety and environmental control standards set by the World Gold Council and international organizations to ensure that chemicals such as cyanide do not negatively affect the ecosystem. The crude gold, after being separated from the ore, will be sent to the smelter to remove impurities and achieve the desired purity, usually 99.5% or higher. This process includes two steps: smelting and refining. The gold is heated at high temperatures to remove impurity metals such as silver, copper. Electrolytic or chemical methods can then be used to achieve the highest purity, resulting in a pure gold product ready for the market. After refining, the gold is cast into bars or coins of the required size and purity. The gold products are then carefully packaged for shipping to banks, jewelry manufacturers, or investment institutions around the world. The World Gold Council requires its member companies to adhere to international standards. They are required to set guidelines to ensure that mining activities are environmentally friendly, responsible to local communities, and comply with international law. Companies regularly test the quality of water, air, and soil in the mine area to ensure there is no pollution or negative impact on the living environment. Companies are encouraged to invest in infrastructure, education, and health projects in the areas surrounding the mine, helping to improve the lives and create jobs for local communities. The modern gold mining and production process, supported and monitored by the World Gold Council, includes many steps from prospecting, permitting, mining, processing, to refining and minting gold. They are committed to supporting companies to conduct responsible, safe, and sustainable gold mining, ensuring that gold is mined and produced to the highest standards, benefiting communities and protecting the environment.
reciprocal in order to transmit the torque to the large end of the connecting rod. These are also known as connecting rod bearings. 2. Main journals. Journals are attached to the engine block. These bearings hold the crankshaft and keep it rotating in the engine block. This bearing is, for example, a plain bearing or journal bearing. The main bearings vary from engine to engine, often according to the forces exerted by the engine. 3. Crank web. The crank web is the most essential part of the crankshaft. The crank web connects the crankshaft to the main bearing journals. 4. Counterweights. The counterweights are a type of weight that applies an opposing force that gives balance and stability to the crankshaft. These bearings, usually, older types, use separate washers. 6. Oil passage and oil seals. The crankshaft oil passage passes oil from the main bearing journals to the large end journals. Usually, the hole is drilled in the crank web. When the crank pin is in an up position and combustion forces push the connecting rod down, oil can penetrate between the journal and the bearing. The crankshaft extends slightly beyond the crankcase at both ends. This will cause oil to leak from these ends. Oil seals are provided to keep oil out of these openings. There are two main oil seals connected at the front end and the rear end. This can result in longer production times compared to other casting methods. There are constraints on the size of the parts that can be produced. Large parts may be difficult to cast due to the limitations of the ceramic molds and the handling of molten metal. Ensuring the quality of the final product can be challenging due to the many variables involved in the process. This requires stringent quality control measures. Casting parts with intricate internal cavities can be challenging. Walzen IRLE GmbH is a renowned manufacturer with nearly 200 years of experience in producing high-tech cast products, including rolls, pistons, and wear-resistant castings. Walzen IRLE specializes in the production of various types of rolls used in different industries. Their rolls are known for their durability and high performance. High-quality raw materials are melted and cast into molds to form the basic shape of the rolls. The cast rolls undergo heat treatment to enhance their mechanical properties, such as hardness and strength. Precision machining processes are used to achieve the desired dimensions and surface finish. Each roll is subjected to rigorous quality control tests to ensure it meets the required standards. Meanwhile, the production of pistons at Walzen IRLE involves several key steps. High-grade materials are chosen based on the specific requirements of the pistons. The selected materials are cast or forged into the basic piston shape. Advanced machining techniques are used to achieve the precise dimensions and tolerances required for pistons. Various surface treatments, such as coating or nitriding, are applied to enhance the wear resistance and performance of the pistons. Each piston undergoes thorough inspection to ensure it meets the stringent quality standards. Walzen IRLE also produces wear-resistant castings for industries where wear is a significant concern, such as the cement, power plant, and dredging industries. They sources premium materials, such as cast iron, steel, and other alloys, ensuring that their products meet the highest standards of quality. The foundry team carefully prepares molds, ensuring that they are accurate and free from defects. This is a crucial step in producing castings with precise dimensions and intricate details. These methods allow them to produce a wide range of components with varying sizes and shapes. After casting, the components undergo precise machining processes to achieve the desired tolerances and surface finishes. This may involve turning, milling, drilling, and grinding. To enhance the mechanical properties of their products, Walzen IRLE performs various heat treatment processes, such as annealing, hardening, and tempering. This ensures that the components have the necessary strength, hardness, and toughness for their intended applications. Throughout the production process, rigorous quality control measures are implemented to ensure that the products meet the highest standards. This includes inspections, testing, and documentation. Walzen IRLE's commitment to continuous research and development, along with their close cooperation with machine builders and plant operators, has made them a leader in the industry. Their products are designed to minimize wear-related costs and optimize the lifetime of components. Schaeffler, a leading global automotive and industrial supplier, is renowned for its high-quality precision bearings. Their manufacturing process involves a series of intricate steps, ensuring exceptional performance and durability. Schaeffler uses premium-grade steel alloys, specifically designed for bearing applications, ensuring optimal strength, hardness, and wear resistance. The steel undergoes various heat treatment processes, such as hardening, tempering, and carbonizing, to achieve the desired mechanical properties. Large bearing components are often produced through forging, a process that involves shaping the steel into the desired form using pressure. Precision machining techniques, like turning, milling, and grinding, are employed to create intricate shapes and tolerances. For smaller rolling elements, balls and rollers, wire drawing is used to create the desired diameter and shape. To achieve the required precision and surface finish, grinding and lapping processes are carried out. Cages. By following these meticulous steps, Schaeffler produces precision bearings that are widely used in industries such as automotive, aerospace, machinery, and electronics, where reliability and performance are critical. Schaeffler has been producing bearing supports for wind turbines for over 30 years, offering reliable and cost-effective solutions for the wind power sector. These bearings support the rotor shaft, which is crucial as it bears all the forces induced by the wind. They are designed to handle highly dynamic loads and operating conditions. With increasing megawatt ratings, wind turbine gearboxes require larger and higher capacity bearings. Schaeffler's bearings are designed to meet these specific requirements, ensuring reliable operation under challenging conditions. Generators in wind turbines are subject to high vibration loads, which can negatively impact the bearings and lubricant. Schaeffler's bearings are designed to withstand these conditions, ensuring long-term reliability. Wind tracking and blade adjustment bearings are used in systems that align the wind turbine optimally to the wind, preventing extreme loads and allowing cost-effective operation. They are crucial for the azimuth drives and gearboxes that adjust the turbine's position. Schaeffler has developed innovative solutions to prevent white etching cracks, WEC, and ensure high equipment availability through condition monitoring. Schaeffler uses state-of-the-art calculation and simulation programs to design optimal bearings for wind power applications. They conduct realistic tests on their ASTRAOS test rig to ensure the highest quality and reliability. Schaeffler bearings are designed to handle a wide range of extreme weather conditions, ensuring reliable performance in various environments. Schaeffler uses optimized bearing seals to protect against harsh weather conditions. These seals are designed to prevent the ingress of contaminants such as sand, dust, and saltwater, which are common in extreme environments. Schaeffler bearings are capable of operating in a wide temperature range, from -30 degrees Celsius in Arctic regions to 60 degrees Celsius in subtropical climates. This ensures that the bearings can perform reliably in both extremely cold and hot conditions. The bearings are made from materials that offer high resistance to corrosion, which is essential for applications in coastal or offshore environments where exposure to saltwater is a concern. Schaeffler bearings are designed to withstand high dynamic loads and varying operating conditions. This includes the ability to handle sudden load changes and extreme peaks, ensuring long-term reliability. The use of special lubricants that can perform well under extreme temperatures and environmental conditions helps in maintaining the performance and longevity of the bearings. Schaeffler employs advanced condition monitoring systems to continuously assess the performance of the bearings. This helps in early detection of potential issues and ensures timely maintenance, thereby preventing failures. These features make Schaeffler bearings suitable for a wide range of applications, including wind turbines, where they are exposed to extreme weather conditions. Maintaining Schaeffler bearings properly is crucial to ensure their longevity and optimal performance. Here are some recommended maintenance practices. 1. Regular inspection. Conduct regular visual inspections to check for signs of wear, corrosion, or damage. Use condition monitoring tools to detect early signs of potential issues.
Horsberg & Scott is one of the world's leading companies specializing in the design, manufacture and maintenance of industrial gear systems. Founded in 1886 in Cleveland, Ohio, USA, the company has built a reputation for precision engineering, high quality, and the ability to meet the diverse needs of industries. From mining and energy to steel and cement production, Horsberg & Scott provides custom gear solutions that optimize the performance of critical equipment. Horsberg & Scott uses modern technology and advanced processes to manufacture industrial gears with high precision. The company uses leading design and simulation software to create gear designs that best suit each customer's requirements. This ensures accuracy right from the planning stage. New generation CNC machines allow gears to be machined with extremely high precision, minimizing errors and ensuring consistent quality in every product. Horsberg & Scott uses heat treatments such as carburizing, surface hardening and controlled quenching to increase the strength, hardness and load-carrying capacity of the gears. Ultrasonic, magnetic and magnetic particle testing technologies are used to detect potential defects in the material without compromising the quality of the product. Take a look at the gear manufacturing process at Horsberg & Scott to see how they make excellent gears. Based on the customer's requirements, design engineers will create detailed 3D design drawings of the gears. Then, machining programs will be programmed to control CNC machines. High-quality steel blanks are rough machined on CNC lathes and mills to create the basic shape of the gears. Gear cutting is performed using specialized machines, ensuring profile and pitch accuracy. Gears are heat-treated to enhance their mechanical properties, enabling them to withstand high pressures under severe operating conditions. After heat treatment, the gears are finished, grinded or lapped, to achieve the highest dimensional accuracy and surface finish. Each gear is thoroughly inspected using state-of-the-art measuring equipment, including a 3D gear profiler, to ensure compliance with specifications. Gears are shipped to customers with detailed installation and maintenance instructions. Horsberg & Scott also provides an installation service if required. With advanced technology, strict manufacturing processes, and extensive experience, Horsberg & Scott has established itself as one of the world's leading gear manufacturers. Their products are highly regarded for their quality, durability, and performance, meeting the needs of the most demanding customers. Horsberg & Scott gears stand out from other manufacturers thanks to a number of unique factors, including quality, advanced technology, customer support, and the ability to customize to customer needs. Horsberg & Scott has been in the industrial gear manufacturing business for over 130 years. This gives them a huge advantage in experience, engineering skills, and the ability to solve complex requirements that few competitors can match. They have designed and manufactured giant gears for heavy industries such as energy, mining, and steel. The company focuses not only on manufacturing, but also on understanding specific applications, thereby providing the most suitable and efficient solutions. Horsberg & Scott is one of the few manufacturers that can manufacture extremely large and complex gears, gear diameters up to 40 feet, over 12 meters, capable of handling heavy loads and operating reliably in harsh conditions. This makes them the preferred choice for large-scale industrial projects requiring specialized gears. Horsberg & Scott applies strict quality control from raw materials to finished products. Alloy steels are carefully selected to ensure durability and wear resistance. Advanced CNC equipment and gear cutting machines ensure the accuracy of tooth profile and pitch. Heat treatment optimizes load capacity and extends gear life. In addition, all products undergo non-destructive testing (NDT) to ensure that there are no defects. Unlike many other manufacturers that offer standard products, Horsberg & Scott stands out for its ability to customize to customer needs, based on specific load, speed, and operating environment requirements. Their gears can be designed to replace or upgrade a customer's existing gear system, regardless of which manufacturer originally supplied the system. Horsberg & Scott continuously updates its manufacturing technology to maintain its leading position, such as 3D tooth profile measurement system, to ensure the highest geometric accuracy of gears, integrating numerical simulation analysis (FE) to analyze stress and optimize design from the very beginning. Controlled cooling technology helps gears achieve the optimal balance between surface hardness and core toughness. Not every manufacturer can meet the requirements from many fields like Horsberg & Scott. Their products serve the mining, wind energy, steel, and cement industries. Horsberg & Scott stands out not only because of its experience and modern technology, but also because of its focus on quality, customization, and outstanding support services. This is the reason why the company is trusted by partners in many industries, especially in projects that require high precision and durability. Bevel gear vertical shafts are a key component in many industrial drive systems, especially in applications that require changing the direction of drive from horizontal to vertical, or vice versa. Bevel gears are commonly used in machine tools, industrial gearboxes, turbines, and pumping systems. To ensure performance and longevity, the manufacturing process of bevel gear vertical shafts requires high precision and strict quality control. Eurocopter, now Airbus Helicopters, is one of the world's leading manufacturers of helicopters and complex mechanical components, including bevel gear vertical shafts used in helicopter drive systems. The differences in their manufacturing processes are mainly due to the special requirements of the aviation industry, which require high precision, lightweight, and extremely high load capacity. Eurocopter uses the most modern technologies to ensure the highest standards of the aviation industry. Advanced 5-axis CNC machines are used to machine shafts and bevel gears with tolerances in the micrometer range. This ensures absolute concentricity and precise fit between the gears in the gearbox. Eurocopter uses milling and tooth-cutting machines developed by itself or by its aerospace partners, with parameters optimized for high-speed applications and fluctuating loads. Prior to machining, the material is thoroughly analyzed using an electron microscope to ensure there are no hidden defects. Eurocopter's heat treatment process is designed to meet the demanding requirements of helicopter gearboxes. Gears are treated in a vacuum environment to minimize the risk of surface oxidation and achieve optimum hardness without increasing weight. After hardening, the gears are tempered at high temperatures to reduce internal stresses, increasing service life under fluctuating loads. Gear samples are cut for hardness, carburizing depth and grain structure to ensure there is no distortion or misalignment throughout the entire batch. Eurocopter uses advanced software to simulate the stresses, vibrations, and temperatures that affect shafts and bevel gears throughout the product lifecycle. Based on the simulation results, the design is optimized to minimize wear and increase load capacity over long periods of time. Especially in helicopter applications, gear and shaft components are optimized to reduce friction and heat generated during high-speed operation. Eurocopter's manufacturing process is highly automated, allowing for consistent quality products even in large quantities. Let's take a look at the main steps in their manufacturing process. Eurocopter often uses high-quality alloy steels, such as 20 CRMNTI, 18 Cernimo 7-6, due to their good load capacity, high fatigue strength, and good machinability. The steel billets are cut, initially shaped, and surface defects are removed. This process ensures the material is homogeneous before machining. They use CNC lathes to machine the shaft with basic dimensional parameters, ensuring straight and concentric shafts. CNC milling machines or hobbing machines are used to form the basic shape of the gears. The surface of the gears is treated in a carbon-rich environment to increase the surface hardness, while maintaining the toughness of the core. Eurocopter uses specialized tooth-cutting machines, such as Gleason or Klingelnberg machines, to machine bevel gears with precise profiles. Ensure the gears have precise profiles, uniform tooth pitch, and no eccentricity. This process helps improve transmission efficiency and reduce noise during operation. After machining, the shaft and gears are assembled and tested for compatibility. Ensure the gears fit precisely, without slipping or vibration during operation. The bevel gears are coated with a protective layer to resist environmental factors such as humidity or chemicals. Holroyd Precision Rotors is a world leader in the precision manufacturing of screw rotors and compressor components. With a long history and continuous innovation, Holroyd has become a trusted supplier to high-performance industries such as energy, aerospace, oil and gas processing. The company is particularly renowned for its advanced technology and modern manufacturing processes, resulting in products that are durable and perform exceptionally well. Holroyd develops and uses its own line of advanced CNC gear cutting and grinding machines, optimized for the manufacture of screw rotors and industrial gears with extremely high precision, less than 5 microns. Holroyd uses aerodynamic simulation and geometry optimization software to design screw rotors. The rotors are designed to optimize airflow, reduce energy consumption, and reduce operating noise. Holroyd uses proprietary grinding technology to produce smooth and precise rotor teeth, ensuring maximum transmission efficiency and reduced friction. The smooth grinding surface increases product life and reduces energy loss. Holroyd uses high-quality alloys and special heat treatment technology to increase the strength, hardness, and fatigue resistance of rotors and gears. The blank is cut and machined to approximate dimensions and shapes. This ensures material savings in subsequent machining steps. Using CNC milling machines, Holroyd forms the basic shape of the worm and rotor teeth. This shape is then refined in subsequent steps. The rotor and worm teeth are surface treated to increase hardness and wear resistance in high-pressure environments. After hardening, the rotor is tempered to ensure that there are no internal residual stresses, reducing the risk of cracking or deformation during use. Holroyd uses the most advanced 5-axis CNC grinding machines to fine-tune the worm teeth. The teeth are ground to the highest precision to ensure a perfect fit between the screw rotor and other components of the air compressor. The smoothness of the teeth reduces friction, noise, and wear over the life of the product. The rotors are assembled and tested under real operating conditions, measuring pressure, airflow, and noise. Holroyd products are used not only in the energy and aerospace industries, but also in the food processing, pharmaceutical, and chemical industries. Holroyd Precision Rotors is the epitome of excellence in the manufacturing of screw rotors and air compressors. With advanced technology, rigorous quality control processes, and the ability to customize products, Holroyd ensures that their products not only meet but exceed the expectations of customers in the most demanding industries.
Walzen IRLE GmbH is a renowned manufacturer with nearly 200 years of experience in producing high-tech cast products, including rolls, pistons, and wear-resistant castings. Their rolls are known for their durability and high performance. High-quality raw materials are melted and cast into molds to form the basic shape of the rolls. The cast rolls undergo heat treatment to enhance their mechanical properties, such as hardness and strength. Precision machining processes are used to achieve the desired dimensions and surface finish. Each roll is subjected to rigorous quality control tests to ensure it meets the required standards. Meanwhile, the production of pistons at Walzen IRLE involves several key steps. High-grade materials are chosen based on the specific requirements of the pistons. The selected materials are cast or forged into the basic piston shape. Advanced machining techniques are used to achieve the precise dimensions and tolerances required for pistons. Various surface treatments, such as coating or nitriding, are applied to enhance the wear resistance and performance of the pistons. Each piston undergoes thorough inspection to ensure it meets the stringent quality standards. Walzen IRLE also produces wear-resistant castings for industries where wear is a significant concern, such as the cement, power plant, and dredging industries. They sources premium materials, such as cast iron, steel, and other alloys, ensuring that their products meet the highest standards of quality. The foundry team carefully prepares molds, ensuring that they are accurate and free from defects. These methods allow them to produce a wide range of components with varying sizes and shapes. After casting, the components undergo precise machining processes to achieve the desired tolerances and surface finishes. This may involve turning, milling, drilling, and grinding. To enhance the mechanical properties of their products, Walls & IRLE performs various heat treatment processes, such as annealing, hardening, and tempering. This ensures that the components have the necessary strength, hardness, and toughness for their intended applications. Throughout the production process, rigorous quality control measures are implemented to ensure that the products meet the highest standards. This includes inspections, testing, and documentation. Their products are designed to minimize wear-related costs and optimize the lifetime of components. Simplecamp GSRI is renowned for its ability to produce exceptionally large and complex castings, including hand-formed spheroidal graphite cast iron castings weighing up to 320 tons. This impressive feat has earned them a world record. Spheroidal graphite cast iron, also known as ductile iron, is chosen for its excellent mechanical properties, including high strength, toughness, and ductility. The spheroidal, nodular, graphite structure enhances these properties compared to traditional flake graphite cast iron. The production involves melting iron at high temperatures, around 1,350 degrees Celsius, and pouring it into molds. For the 320-ton casting, Simplecamp used 5 ladles of molten iron. The process requires precise control to ensure uniformity and prevent defects. Given the size and complexity of these castings, hand molding is often employed. Skilled craftsmen use specialized tools to shape sand into the desired mold cavity. Cores, which form the internal cavities of the casting, are also created using similar techniques. The necessary spheroidal graphite cast iron is melted in large furnaces, ensuring precise chemical composition and temperature control. The molten iron is carefully poured into the prepared mold, filling every crevice and ensuring a uniform casting. The casting is allowed to cool gradually under controlled conditions to prevent cracking or distortion. As the iron cools, it solidifies, forming the desired shape with the characteristic spheroidal graphite microstructure. Once solidified, the casting is carefully removed from the mold. Depending on the specific requirements, the casting may undergo machining processes to achieve precise dimensions and tolerances. Rigorous quality control measures are implemented to ensure that the casting meets the specified standards for strength, hardness, and other properties. These large castings are used in heavy machinery and industrial applications, such as the lower press beam for a 12,500-ton closed-die forging press. Such components are critical for industries requiring high-strength and durable materials. Simplecamp's achievement of casting a 320-ton component set a world record, showcasing their expertise and capability in handling large-scale projects. Producing castings of this magnitude presents several unique challenges. Maintaining the stability of the large, hand-formed molds during pouring and cooling is crucial. Ensuring consistent temperature control throughout the casting process is essential for achieving the desired material properties. Safely handling and transporting these massive castings requires specialized equipment and expertise. Large castings, such as those produced by Simplecamp GSRI, are utilized in several industries due to their strength, durability, and ability to be customized for specific applications. There are some key industries that rely on large castings. 1. Power generation. Large castings are essential in the construction of turbines, generators, and other components for power plants, including nuclear, hydroelectric, and thermal power stations. 2. Mining and earthmoving. Heavy machinery used in mining and earthmoving, such as excavators, bulldozers, and dump trucks, often incorporate large castings for critical structural components. 3. Marine and offshore. The shipbuilding industry uses large castings for parts like engine blocks, propellers, and structural components of ships and offshore platforms. 4. Oil and gas. Equipment used in the extraction, processing, and transportation of oil and gas, such as drilling rigs, pumps, and compressors, often includes large castings. 5. Construction. Large castings are used in the construction of bridges, buildings, and infrastructure projects, providing the necessary strength and stability for these structures. 6. Aerospace. The aerospace industry uses large castings for components in aircraft and spacecraft, including engine parts and structural elements. 7. Heavy machinery, industries that manufacture heavy machinery for various applications, such as steel mills, paper mills, and cement plants, rely on large castings for their equipment. These industries benefit from the robustness and versatility of large castings, which can be tailored to meet specific requirements and withstand demanding operational conditions. Transporting and installing large castings involves several specialized steps to ensure safety and precision. Before transportation, the casting is carefully inspected and prepared. This includes cleaning, applying protective coatings, and securing any loose parts. Heavy-duty cranes and lifting equipment are used to load the casting onto transport vehicles. This process requires precise handling to avoid damaging the casting. Specialized transport vehicles, such as multi-axle trailers or self-propelled modular transporters, SPMTs, are used to carry the heavy load. These vehicles are designed to distribute the weight evenly and navigate through various terrains. Detailed route planning is essential to ensure the casting can be transported safely. This includes checking for weight restrictions on roads, bridges, and tunnels, and obtaining necessary permits. The transport is often accompanied by escort vehicles and monitored throughout the journey to ensure safety and address any issues that may arise. The installation site is prepared in advance, including creating a stable foundation and ensuring all necessary equipment and personnel are ready. Once the casting arrives at the site, it is carefully positioned using cranes and other lifting equipment. This step requires precise alignment to ensure the casting fits correctly into its designated place. The casting is then secured in place using bolts, welds, or other fastening methods. This ensures the casting remains stable and can withstand operational stresses. The casting is integrated with other components and systems. This may involve connecting it to machinery, piping, or electrical systems, depending on its application. After installation, the casting and its connections are thoroughly tested and inspected to ensure everything is functioning correctly and meets safety standards. These steps require careful planning, coordination, and the use of specialized equipment to handle the size and weight of the castings. Waldrich Coburg specializes in high-precision machining of large components, including diesel engine blocks for companies like Wärtsilä. Diesel engine blocks are typically made from materials that offer a balance of strength, durability, and heat resistance. The most common materials used include cast iron, known for its exceptional strength and durability. Cast iron is a popular choice for heavy-duty applications. It can withstand high pressures and temperatures, making it ideal for diesel engines. The second thing is aluminum. This material is lighter than cast iron, which can improve fuel efficiency and vehicle performance. Aluminum engine blocks are often used in applications where weight reduction is crucial. And the must-have material is steel. Steel offers a good balance between strength and weight. It is used in various engine designs to provide durability while keeping the engine relatively lightweight. Each material has its advantages depending on the specific requirements of the engine and its intended use. For instance, Cast iron is often preferred for its robustness in high-stress environments, while aluminum is chosen for its weight-saving benefits. How Waldrich-Coburg machines are used in the machining of diesel engines for Wärtsilä. 1. Crankshaft machining, which include horizontal lathes machines used to turn and finish the crankshaft journals and pins, ensuring precise tolerances and surface finishes, and vertical lathes machines are used to machine the counterweights and crank pins on the crankshaft. 2. Cylinder block machining that include horizontal boring machines used to bore the cylinder bores and machine the crankshaft bearing seats, and vertical milling machines used to mill the faces and surfaces of the cylinder block. 3. Cylinder head machining machines are used to mill the valve seats and other surfaces on the cylinder head and to bore the valve guide holes. Texmo Blank manufactures long lifespan steel, aluminium, cobalt and nickel-based precision castings in air and vacuum at modern factories in North America, Europe and Asia. They are known for solving complex manufacturing challenges, industry-leading turnaround times and our stringent in-house quality control. Let's dive into the details of investment casting, its processes, and specific applications, including those by Fingers Blank. Investment casting, also known as lost wax casting, is a precision casting process used to create intricate and complex metal parts with high dimensional accuracy and fine surface finishes. This method has been used for thousands of years and is valued for its ability to produce components with accuracy, repeatability, versatility, and integrity in a variety of metals and high-performance alloys. A wax model is created using a mold or 3D printing. The wax model is typically attached to a wax tree for support during the subsequent steps. The wax tree is dipped into a slurry of refractory ceramic material. This slurry coats the wax model, forming a thin ceramic shell around it. This process is often repeated several times to create a sufficiently thick ceramic shell. The ceramic shell is heated to melt and remove the wax, leaving a hollow cavity in the shape of the desired metal part. Molten metal is poured into the ceramic mold. The metal fills the cavity, solidifying into the desired shape. Once the metal has cooled, the ceramic shell is broken away to reveal the finished casting. The casting may require additional finishing processes such as machining, grinding, or polishing to achieve the desired surface finish and tolerances. Investment casting is used in a wide range of industries, including aerospace, turbine blades, engine components, and aircraft parts. Automotive, engine components, transmission parts, and brake systems. Medical, dental implants, surgical instruments, and medical devices. Jewelry, rings, necklaces, and other intricate jewelry pieces. Industrial, pump components, valves, and gears. Investment casting offers several advantages that make it a preferred method for producing complex and high-precision metal parts. Investment casting can produce highly intricate parts with complex internal geometries that are difficult or impossible to achieve with other processes. This method delivers a smooth surface finish, minimizing the need for additional post-processing or machining, which can reduce production time and cost. Investment casting achieves tight tolerances, ensuring accuracy and consistency across all parts. This is particularly useful in industries like aerospace, where precision is critical. The process is highly versatile and can be used with a variety of materials, including various metals and alloys. Investment casting produces minimal waste, making it a cost-effective solution for diverse manufacturing needs. It is scalable, allowing for the production of both small and large batches, making it useful for both prototyping and high-volume production. These advantages make investment casting an ideal choice for industries requiring detailed and precise components, such as aerospace, automotive, medical devices, and jewelry. While investment casting offers many advantages, it also has some limitations and challenges. The process can be expensive, especially for small production runs. The cost of creating the wax patterns and ceramic molds can add up, making it less economical for low-volume production. Investment casting involves multiple steps, including creating wax patterns, building ceramic shells, and removing the wax. This can result in longer production times compared to other casting methods. There are constraints on the size of the parts that can be produced. Large parts may be difficult to cast due to the limitations of the ceramic molds and the handling of molten metal. Ensuring the quality of the final product can be challenging due to the many variables involved in the process. This requires stringent quality control measures. Casting parts with intricate internal cavities can be challenging. The process may not be suitable for parts requiring deep or small diameter holes. While investment casting is versatile, not all materials are suitable for this process. Some metals and alloys may not perform well or may be difficult to cast. Despite these challenges, investment casting remains a valuable method for producing high precision and complex parts, especially when the benefits outweigh the limitations.